All right, problem number 2. Given the picture below, line P is parallel to line Q, and line M is parallel to line N. Find the following measures if the measure of angle 16 is 74 degrees. So angle 16, we know, is 74 degrees. I'll come over here and look at these in a minute, but I see another angle up here that's also 74 degrees that I could mark right away. What other angle is also 74 degrees? Angle 14. Those are vertical angles. So angle 16 and angle 14 are 74 degrees. 13 and 16 are not the same. What is the name for this pair for 13 and 16? (13 and 16). What is the name for that pair? They're a linear pair. Linear pair angles, congruent, supplementary, or neither? Supplementary. What does supplementary mean? Adds to 180. So I know the measure of angle 13 plus the measure of angle 16 equals 180. So I have the measure of angle 13 plus 74 degrees equals 180. So then I would subtract 74 from both sides. So how big is angle 13? (106). Yes, this is 106 degrees. So angle 13 up here is 106 degrees. What other angle right here is also 106 degrees? 15. 15 and 13 are vertical angles. So this one is also 106. Angle 11 is down here. And now I'm looking at question A here, the measurement of angle 11. Angle 11 is right here. Can you find a relationship between angle 11 and one of the angles up here? 15 and 11, what do we call that special angle pair? Corresponding. Are corresponding angles congruent or supplementary? Not for corresponding. Corresponding are congruent. The other ones that start with C, the consecutive interior, consecutive exterior, those are supplementary, but corresponding are congruent. Yes. So because corresponding angles are congruent, the measurement of angle 11 is 106. You're welcome. Measurement of angle 4. Angle 4 is over here. Can we find a relationship between angle 4 and one of these angles? (4 and 16). What's the name of that special angle pair? Those are also corresponding. So how big is angle 4 then? 74 degrees. Because corresponding angles are congruent. Angle 8 is down here. Are there any lines that touch angle 8 that also touch these? No, so I'm going to need to find a different relationship. But didn't we just say that angle 4 was 74 degrees? Angle 4 is 74 degrees, so I'm going to mark that. Can I find a relationship between angle 4 and angle 8? Corresponding, so how big is angle 8? 74 degrees, yes. Because they are corresponding. Angle 3, right here. Well, what's the relationship between 3 and 4? Linear pair. What do we know about linear pair angles? They add to 180, so how big is angle 3? 106 degrees, yes. Perfect. What else would you guys like to see? Yes. Number 3, absolutely we can go do number 3 next. If the measure of angle 2 equals 8x minus 14, and the measure of angle 6 equals 2x plus 28, and the measure of angle 3 equals 3y minus 33, find x and y so that line B is parallel to line C. And the first thing I want to tell you is that line C, I don't know why, but this is in the wrong spot. C shouldn't be here. C should be here. I don't know why it, like, that one line ended up with 2 names. It said A up here, but it said C down here. This should be A, and these 2 should be B and C. I apologize for the confusion. All right, measure of angle 2 is 8x minus 14. Angle 2 is right here. 8x minus 14 degrees. And then we have the measure of angle 6, which is 2x plus 28 degrees. Angle 6 is here. 2x plus 28 degrees. And then we have the measure of angle 3, which is 3y minus 33. Angle 3 is right here. 3y minus 33 degrees. Find x and y so that line B is parallel to line C. We need to find x first. The 2 angles that have x are angle 2 and angle 6. Are those interior, exterior, or one of each? Exterior. Same side or opposite sides of the transversal A? Opposite. What do we call opposite side in or exterior angles? Alternate exterior angles. Angle 2 and angle 6 are alternate exterior angles. Are alternate exterior angles congruent or supplementary? Congruent. So I can say angle 2 is congruent to angle 6. If 2 angles are congruent, what does that mean about their measurements? They're the same. So the measurement of angle 2 equals the measurement of angle 6. In the place of angle 2, I'm going to put 8x minus 14. In the place of angle 6, I'm going to put 2x plus 28. Now I need to get my x's on the same side, so I'm going to minus 2x from both sides. I need you to turn the music off, please. I need you to take the earbuds out. What is 8x minus 2x? 6x. So I have 6x minus 14 equals 28. Then I add 14 to both sides. That would give me 6x equals what? 42. Then we divide both sides by 6. And how big is x? X is 7. All right. Now we still need to find y. Y is right here. Is angle 3 interior or exterior? Interior. Angle 6 is exterior. Are 3 and 6 in matching corners? No. Angle 3 is on the bottom. Angle 6 is on the right. So they're not in matching corners. So I don't have a name for this angle pair. What about this angle pair? Do we have a name for that? What do we call angle 2 and angle 3? Linear pair. Angle 2 and angle 3 are a linear pair. Are linear pair angles congruent or supplementary? Supplementary. So I can say the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. Well, angle 2 is 8x minus 14. So I'm going to substitute that in. Plus the measurement of angle 3 is 3y minus 33. And that's equal to 180. I have a problem here. I have an x and a y in the same equation together. How can I fix that? Substitute 7 in the place of x. So I have 8 times 7 minus 14 plus 3y minus 33 equals 180. What is 8 times 7? 56 minus 14 plus 3y minus 33 equals 180. I'm going to take the 56 minus 14 and the minus 33 and combine those all together at the same time. What do we get when we combine all those together? (56 minus 14 minus another 33). What do I get when I combine my constants? 9. 3y plus 9 equals 180. And then I'm minus 9 from both sides. What is 180 minus 9? 171. Bring my work over here now. 3y equals 171. Then we divide both sides by 3. What is 171 divided by 3? 57. So x is 7 and y is 57. What else would you guys like to see? Number 9, absolutely. Problem number 9. Complete the following proof. The given information is that line J is parallel to line K. So that's my first statement. The reason I can make that statement is because it is given. The thing I'm trying to prove, which will be my last statement, is that angle 1 and angle 6 are supplementary. So that comes down here. Angle 1 and angle 6 are supplementary. So I know line J and K are parallel. I'm going to come up here and mark that on the picture. Put my little arrows on those lines, meaning parallel. They gave me my second statement. My second statement is that angle 1 is congruent to angle 5. Well, here's angle 1, and here's angle 5. What kind of angles are those? Corresponding. They're in matching corners. These are corresponding angles. So we're going to say that they are congruent by the corresponding angles theorem. When I know the lines are parallel, then I can say the corresponding angles are congruent. We started off by knowing the lines were parallel, so we can use the corresponding angle theorem to say that the angles are congruent. Angle 5 and angle 6 are supplementary. Well, what kind of angles are 5 and 6? Linear pair. So this is my linear pair theorem. What's the difference between statement 3 and statement 4? What's the difference between statement 3 and statement 4? 1. What did it used to be? 5. So angle 1 replaced angle 5. Why would I be allowed to replace like that? Substitution. There's my substitution property. What else would you guys like to see? 12 and 11. Let's go do 12 and 11 next. Let's do 11 first. And then we'll do 12 right afterwards. Yep. Number 11, you are given the line y equals 1/3 x minus 6. We're going to graph this first. When we go to graph a line that's in this form, what's the first thing we plot? Name, date, and time, and then marker goes right here. -6. Where do I put the -6? On the y-intercept, on the y-axis. So this right here is my y-intercept. So -6 on the y-axis, right down here. And then we have the slope. 1/3 is my slope. So the 1 is my rise. And the 3 is my run. When we run, we always start by running to the right. We get as many points as we can running to the right. So I'm going to go up 1 and right 3. Put down a point. Up 1 and right 3 and put down a point. I can't go any further to the right, so I'm going to back it up and turn it around. I'm going to go down 1 and left 3, down 1 and left 3. And then I'm going to grab my straight edge, and I'm going to sketch a line through those points. This is my given line. Part A, graph the line that is parallel to the line above and that passes through the point -4, 2. Parallel, do you guys remember about the slope for parallel lines? Close, that's my perpendicular. That's going to be the next one. You're thinking on the right path. Parallel is the same slope. Parallel is the same slope. So what will the slope be here then? If I need it to be the same as the line above, what will the slope be? 1/3. My slope will be 1/3. I want it to go through this point right here. So we plot this point first. So -4, 2. -4, 2 is right here. And then we will use the slope to plot more points. So just like we did when we put our y-intercept down and then we used our slope to count to get more points, I'm going to go to this point right here, which was the point that I plotted, and now I'm going to use the slope to get more points. Up 1 and right 3, which gives me a point right here. Up 1 and right 3, up 1 and right 3, up 1 and right 3. And I can even turn it backwards and go down 1 and left 3 for 1 before I hit the edge of the graph. And then I'm going to sketch my line through those points. This is my parallel line. The given line, the original line, and the parallel line should look like railroad tracks, like they're never, ever, ever going to touch. These two lines should look like railroad tracks. For part B, we want perpendicular to the original line. Perpendicular means opposite sign and reciprocal. Does anybody remember what that word reciprocal means? Yes. We are going to flip the fraction. So what would my perpendicular slope be then? -3/1. We're going to plot this point first. So 1, 6. 1, 6 is right here. And then we will use the slope to plot more points. So -3/1 means I go down 3 and I run 1. We always run to the right. So down 3 and right 1, down 3 and right 1, down 3 and right 1, down 3 and right 1. I hit the edge of the graph going down. I can't turn it around backwards at all because I don't have enough room to go up 3. So I draw my line through my plotted points, and that is my perpendicular line. Nicely done. Let's look at number 12 next. We already talked about this, but parallel means it's going to have the same slope, and perpendicular means it's going to have the opposite sign and reciprocal. Opposite sign and reciprocal slope. Reciprocal means to flip the fraction. So let's look at the line they gave us. What is the slope? Which of those numbers is the slope for this given line? 1/8. This is the slope. So what will the parallel slope be then? What will the parallel slope be? 1/8. Remember, parallel has the same slope, so this will be 1/8. Which one of these lines over here has the parallel slope? C. 1 over 8. This is the same slope, so this one is parallel. Perpendicular slope is the opposite sign and the reciprocal. So what would the perpendicular slope be? -8 over 1. Can I simplify that at all? Can I divide that and get a whole number? -8. So my perpendicular slope is -8 over 1, or just -8. Which one of these lines over here has the perpendicular slope? B. Here's my perpendicular slope. So this one is perpendicular. So what's the slope on part A? Yeah. Part A, the slope is 8. But that's not my parallel slope or my perpendicular slope. So this one would be neither. What else would you guys like to see from the review? Yes. Number 10? Absolutely, we can do number 10. Number 10. Number 10 says, given the points -3, -14, and 5, -2, find the slope of the line parallel and perpendicular to the line that goes through the given points. So our slope formula is m equals y2 minus y1 over x2 minus x1. I will give you this formula on the test. You do not have to memorize this. I will give you the formula on the test. So we have 2 points up here. One of them needs to be 0.1 so that I can get an x1, y1. The other one is 0.2 so I can get an x2, y2. So I'm going to let -3, -14 be my x1, y1. And I'm going to let 5, -2 be my x2, y2. So then I start substituting into this formula. The first number that I want is y2. What is my y2? -2. So I have -2 minus, what is my y1? -14. Over x2, what is x2? 5. Minus x1, what is x1? -3. On the top and the bottom, we are subtracting a negative. What happens in both spots? Turns into a positive. So I have -2 plus 14 over 5 plus 3. What is -2 plus 14? 12. You'll need that paper right there for Thursday. 5 plus 3? 8. If I do 12 divided by 8 on my calculator, will I get a whole number or a decimal? I'm going to get a decimal. I don't want decimals for slope. We never want decimals for slope. Whole numbers are fractions only. So this is going to have to stay as a fraction, which means I need to make sure it's fully reduced. What's the biggest number you can think of that goes into both 12 and 8? 4 goes into both. What is 12 divided by 4? 3. What is 8 divided by 4? 2. What does this symbol mean, these two vertical lines? Parallel. And parallel lines have the same slope. So what is the slope for the line parallel here? 3 over 2. What does this upside down capital T mean? Perpendicular. That means perpendicular. Perpendicular is opposite sign and reciprocal. So what will the slope for the perpendicular line be? -2/3, yes. Got right about 10 minutes left. That's enough time for 1 or 2 problems, depending on the length. Yes? You can just write 3/2. The extra notes that I'm putting down underneath are to help you understand why we're doing that. But yes, on the test itself, if it says slope for parallel line, you just need to write the number there. Yep. Yes. 7 and 14. So let's do 7 first, and then we'll see if we have time for 14. Use the given information to determine which lines must be parallel. So we know that angle 2 is congruent to angle 6. Well, here's angle 2. Here's angle 6. What's the transversal that connects them? C. Which line does not touch either angle? D. So what are the 2 lines that would have to be parallel? A and B. So A parallel to B. Part B, it says 8 and 9 add up to 180. Here's 8. Here's 9. What's the transversal that connects them? D. Which line does not touch either one? C. So what are the lines that would have to be parallel? A and B again. All right. 9 is congruent to 7. Here's 9. Here's 7. What's the transversal that connects them? D. Which line does not touch either one? C. So which lines would have to be parallel? A and B again. And finally, we have 1 is congruent to 8. Here's 1. Here's 8. What's the transversal that connects them? A. Which line does not touch either one? B doesn't touch either one. So which lines would have to be parallel? C and D. All right, 14 is the next one we're going to go to. 14. Very back page, next to last problem. We are going to name the angle pair, if possible, and we're going to describe their relationship, congruent or supplementary. First 2 angles are 10 and 11. Here's 10. Here's 11. What's the transversal that connects them? M. Which line does not touch either one? I or L. I think it's L. I'm not really sure. But that one right there. So are 10 and 11 interior, exterior, or one of each? Interior. Same side or opposite sides of the transversal? Same side of the transversal. So what do we call that special angle pair? Yes, they're consecutive. Interior or exterior? Interior. Consecutive interior angles. Are consecutive interior angles congruent or supplementary? Supplementary. All right, 6 and 14. Here's 6. Here's 14. What's the transversal that connects them? S. Which line doesn't touch either one? T, so ignore that one. Are 6 and 14 interior, exterior, or one of each? One of each. What's the only named angle pair that we could use if we have one of each? Corresponding. Are these corresponding? Yes, they're in matching corners. Lower right corner, lower right corner. So these are corresponding angles. Are corresponding angles congruent or supplementary? Congruent. All right, 16 right here and 3 right here. What's the transversal that connects them? T. Which line doesn't touch either one? S. Are these interior, exterior, or one of each? Exterior. Same side or opposite sides of the transversal? Opposite. What do we call those? Alternate exterior angles. Are alternate exterior angles congruent or supplementary? Congruent. All right, I have 15 and 11 next. 15 is here, 11 is here. Well, L doesn't touch either one, and S also doesn't touch either one. So there is no transversal. These two angles touch the same two lines. They're side by side. What do we call that special angle pair? Linear pair. This is a linear pair. Are linear pair angles congruent or supplementary? Supplementary. All right. Then we have 3 and 16. 3 is here. 16 is here. What type of angles are those? Alternate exterior angles. We already did this one. We just flipped the angles around the other way. So these are congruent. All right, 6 and 9. 6 is here. 9 is here. What's the transversal that connects them? S. Which line doesn't touch either one? T. Interior, exterior, or one of each? One of each. Same side or opposite sides? Opposite sides. Are we sure it's one of each? Is 6 interior or exterior? Interior. Is 9 interior or exterior? 9 is also, so these are both interior angles. We don't have one of each. They're on opposite sides of the transversal. What do we call those? Alternate interior angles. Congruent or supplementary? Congruent. Alternate interior angles are congruent. Last one. Angle 4 and angle 7. Angle 4 is right here. 7 is right here. What do we call these? Vertical angles. Are vertical angles congruent or supplementary? Congruent. Nicely done. The test review answer key is posted in Canvas already. Test review answer key is posted in Canvas. If you go to modules in Canvas, make sure you go to module 3B, and then you'll scroll down to the bottom of module 3B until you see Tuesday, 9:30. You click on that. Scroll all the way to the very bottom. Down at the very bottom, module 3B test review key. If you click on this, it has all of the problems with all of my work there for you. All the problems with all the work. After school today, There will be videos posted for first, second, third, and seventh period. So you can check out the videos from a different class if you want to see me go over different problems. And don't forget, you will be turning in your test review tomorrow when you come in to take your test. Thursday is the e-learning day. Please make sure that you have that worksheet to go along with the video that is posted in Canvas. That video will unlock Thursday morning at 12:01 a.m. and it will close at 11:59 p.m. on Thursday. So please make sure that you get in and do the assignment on Thursday.